Hello everyone. The topic that we will be discussing is electric field due to a point charge. So first of all, let us understand few important terms like electric field, electric field strength, and electric field lines of force. Electric field lines of force. So, what is electric field? If we have a charge or a systems of charge, we can say, and if a test charge is brought in a region around this system of charge, it will experience an electrostatic force of interaction. So the region around a charge or a system of charge where a test charge experience an electrostatic force of interaction is called electric field. The question may arise, what is the strength of that electric field? The electric field is differed from one point to another. For example, this point A is close to a system of charge and a point B is little bit far away from the system of charge. So what is the strength of the electric field at the point A in compared to the point B? The electric field at A will be much higher than the electric field at the point B. So closer to the systems of charge, larger will be the electric field strength. Then further from the system of charge, smaller will be the strength of the electric field. So the electric field strength is defined as the force per unit test charge in a region of an electric field. So what is electric field strength? The strength of the field is force per unit test charge. So let Q naught here be the test charge. One should be noted that Q naught must be an infinitely small, because if Q naught is large, then it will dislocate the source charge, or it will dislocate this source charge. If it dislocates this source charge, it means if it dislocates this source charge, then it will alter the electric field strength. So therefore, we don't want that. So what we must do that Q naught must be an infinitely small, so that this source of charge will remain stationary. So Q naught here must be an infinitely small. Then let us come to the electric field lines of force. If we have a charge or a source charge to be positive, plus Q, the electric field lines of force will be like this. So this is the electric field line of force. If the source charge or system of charge is negative, then the electric field lines of force will look like this. So since we have an idea about electric field strength, and electric field lines of force. So let us now have a discussion on the electric field due to a point charge. So let us consider a point charge located at the origin. This Q, point charge. So this is x-axis, y, and z. And somewhere at a point P in space, there is a test charge CQ0. Here, we will consider that the force between Q and Q0 is repulsive force. So, the direction of the force is in this direction. Say from here to here, the distance is r, and the position vector we can note as say by r, like this. So now, force on Q0 due to Q is F equal to 1 by 4 pi epsilon naught Q0 divided by, what's distance from Q to Q0? It is R. So here it is a vector, so I can put mod of R square. So in which direction? It is readily outward. So we can write R cap. So what is R cap? R cap can be written as, we have learned from the vector, for any vector A, suppose like this, A mod A into A cap. So A vector is equal to mod A into A cap. So what is R cap then? R cap can be written as R vector divided by mod R. So if you replace R cap by this value, so F is equal to how much? 1 by 4 pi epsilon naught Q naught. So R cap become R vector. So mod of R square into mod of R become mod of R cube. So this is the force. So by definition, what is electric field? Electric field is F by Q naught. So from here, 1 by 4 pi epsilon naught. This Q naught and Q naught will get cancelled. So we can write Q divided by mod of R cube R. So this is the vector representation of electric field at any point due to a point charge Q. So in magnitude, this electric field E is 1 by 4 pi epsilon naught. So Q, so if we take mod, so mod of R with 1 mod of R will get cancelled. So we can write mod of R square. So this is the electric field at any point P due to a point charge Q. So let us have a discussion. Number 1. If the point charge is plus, the electric field lines of force is readily outward. Electric field field lines of force are readily outward. Number 2, if this source charge, if point charge is negative, then electric field lines of force are readily inward. Like we have discussed earlier, if this is plus, then outward. Like this. If it is negative, then the electric field lines of force are readily inward. Like this. And number 3, the magnitude of this electric field follow the inverse square law. So 1 by r square, E is inversely proportional to 1 by r square. So this electric field strength the magnitude of electric field strength follows the inverse square law. So if we view from the charge Q, we can see that these electric field lines, they are spherically symmetric.